example, I have two different groups. I have chlorine and I have fluorine. Now, how should I add numbers? I should start given number by the least vacancy, by the least numbers, and I should be aware of the alphabetical order. So I'll give a chlorine first because chlorine is before fluorine. So it will be 1, 2, 3, 4. Even if I go up, it will be the same. So it is 1 chloro, 4 fluoro, benzene. Here, the same thing. I have 1, 2, 3, 4, 5, 6 atoms or carbons. Now I can start from the left side, given 1, 2, 3, 4, 5, or I can start from the rest, given the bromine, the number 3. If I can start by given the least number for the first alphabetical, I should do this. So it's better to say 3 bromo, 4 chloro. It's correct to say 3 chloro, 4 bromo, or 4 bromo, 3 chloro, but the best scenario is to start with the least number. What about the common names for the halocarbons? The common names is to give the name of the alkyl or the arene or the aromat, which is benzene. And in this case, we will call it biphenyl. And we add the name of the halide. So here, for example, it will be methyl chloride. We can have ethyl chloride. If it's benzene, it will be phenyl. And if it's a double bond like ethene will be vinyl. So this is the name of it. Number 2, we have the group number 2, which is alcohols. The alcohols, they are hydrocarbons, and we add hydroxy group. What is the hydroxy group? It is an OH that's connected to the carbon. Now, how can I make alcohol? We have many steps or many ways. One of the ways is by doing a substitution reaction. The substitution reaction will take place for halocarbon. I take a halocarbon, I add a base to it. Base means it's something that has OH, the hydroxide ion, and it will form a alcohol and salt. All of them, they should be in water or steam water at 100. As you see here, if you remember the double replacement, I just do double replacement reaction. CH3 will take the OH to form alcohol, and the Na will take the Cl to form a salt. The other way is by doing an addition reaction. Addition reaction, it's the same for the halocarbons, the one that we add halogen, but here I will add hydration. Hydration means the addition of water. I bring an alkene and I add water or steam at 100 degrees, and this one will form for me alcohol. So as you see here, I have ethene, alkene, I add water, it becomes ethanol. Now, how do I give a name for the alcohols? In order to give names for the alcohols, depending on the IUPAC system, I name the alkane, then I add the word all. Very simple. Just name the alkane, then add the word all. So here I have methanol, for example. Now, what about if the OH was not on the side? It was in the middle. When I have more than 2 carbons, what should I do now? I should start giving numbers for each carbon. So here 1, 2, 3. So it will be 2 propanol. I should give the least number for the OH. Here also I have phenol. Miss, we don't have something, we call it benzenol. Benzenol does not exist. The name is phenol. So once I have a benzene, the name will be phenol. Here, for example, I have 1, 2, 3, 4, 5 atoms, and I have CH3 as a branch, and I have here the OH. From where should I start? From the OH side. The OH should take the least number, then the others. So here 2 for the OH, and number 4 for CH3, so I'll say 4 methyl 2 pentanol, because I have 5 carbons. Okay, what about if I have more than one OH group? Like sometimes I have 2 OHs or 3 OHs when I add more hydration. At this case, I start giving numbers from the least side. Like here, for example, 2, 3, 4. Then I will say pentane. Then after pentane, I'll add the word tri because I have 3, then all. So it will be 2, 3, 4. Pentane, triol. If I have 2, the same thing. You can't start saying 1, 2, 3, 4 because if you start from the left, this OH will take number 1, which is better. So here I'll have 1, 2, 3, 4. 1, 3 pentane. I have 2, so diol. Okay, what about if I have a branch? If I have a branch, the same, I'll start to give the least numbers for the OH. If I can give the least number for the group, it's okay. So I can say here 1, 2, 3, 4, 5. 2 is the least number for the OH, even if I start from the other side. That's why I started from the right. It's better to start from the group if the OH will not be affected. So here I have 1 methyl, 2, 4 pentane diol. What about the common name? The common name, I name the group, the alkyl, then I add the word alcohol. This one has a name of methyl, so methyl alcohol, phenyl alcohol, ethyl alcohol, and so on. These are the common names. Now, the last thing about the alcohols, the types of alcohols, I should look at the carbon that's connected to the hydroxy. If this carbon is connected to one carbon or to nothing, at this case, I'll say this is primary. If this carbon is connected to two carbons, I'll say it's a secondary alcohol. And if the carbon that's connected to the hydroxy connected to three carbons, I'll say this is a tertiary alcohol. Then, group number 3, it's about ether. Ether has a general formula of ROR. I have O in the middle, oxygen in the middle between two carbons. For the ethers, we just learned about naming them. In order to name them, the shortest way to name them, or the IUPAC way to name them, is to start by the short R, the short parent. Then we will add the word oxy. Then I name the long parent or the long R as it is. So here I have CH3, O, CH2, CH3. The short is CH3, so I'll start by it. I add meth. Instead of methane, I'll add oxy, so methoxy. Then the name of the long one, which is ethane. Here, since the two sides of the O are not the same, so it is asymmetric. Sometimes some of the ethers, they have equal sides for the O, equal hands. So at this time, I will say this one equal or symmetric. How to name it? The same thing. One of them will be a parent, one of them will be a branch. So here I have phenyl, will be the branch, so it is phenoxy, benzene. Here, this one is shortest, so it is methoxy, benzene. Here, this one is the short, propan, so it will be propexy. And this one is the longest one, so it is butane, propexybutane. Here, both of them are the same, so one of them will be a branch, the same as this one, so it will be methoxymethane. What about the common name? The common name is that I name the alkyl, then I add the word ether. If I have double, they are the same, so I'll add the word di. So here they are different, so it will be, depending on the alphabetical order, ethyl, methyl, ether. Here, or the same, depending on the alphabetical order, butyl, methyl, ether. What about if they are the same? This group has a name, or the alkyl has a name of phenyl, so it will be diphenyl ether. And this one, dimethyl ether. The last group, which is the amines or the amines, they are the groups that they are connected to nitrogens, and they are the ones that they form amino acids. We will learn about them later on, the basic formula for amino acids or proteins. What are the general formula for amines? I have primary, secondary, and tertiary amines. When the R or the N is connected to one carbon, I'll say that here it's a primary. You know, miss, that the nitrogen can form 3 bonds. When the nitrogen is connected to 2 carbons, I'll say it's secondary. When the nitrogen is connected to 3 carbons, so no hydrogens, here I have a tertiary amine. How do I name them? We will just learn how to name the primary amines. I name the parent or the hydrocarbon, then I just add the word amine. So here I have methane, amine, propane, amine, benzene, amine. What about if I have a branch? I start giving numbers for the branch. The branch here has number 2, and the amine also has number 2. This is the best scenario. So I'll say 2-methyl 2-propane amine. The common name is that by adding alkyl and the word amine. Alkyl, here, for example, I have methyl amine, phenyl amine. So this is the name of it. What about the boiling point and the melting point for all of them? If we want to rank them from high to low, the first one, they are alcohols because they have a hydroxyl ion and they form a boiling point with water. Then we have the amines because they have a nitrogen, and the nitrogen and sometimes, or we can say it's electronegative, but it's less in electronegativity than the oxygen that I have it in alcohol. Then we have ether. Ether, it has oxygen, but the oxygen is surrounded by 2 carbons that they delete the strength of oxygen. Then halocarbons, and the last ones are the alkenes. The last thing that sometimes miss when they want to make a butter from oil, what they do, the oil is unsaturated, as you know. In order to make it saturated, I do a reaction, an addition reaction of hydrogen. I call it by hydrogenation. Be aware. Hydrogenation, adding hydrogen. Hydration, adding water. They are different. What do? I bring an alkene, something that it's not saturated. I add hydrogen to it, so we make alkane. This is the way how they convert oil to butter in a certain plant. Example here, we have ethene. I add hydrogen, so it becomes ethane. Cyclooctene, for example, there is a double bond. Be aware that the cyclos, they are aliphatic. They are alkenes. They are not aromatic. The aromatic, I couldn't make them by just adding H2. The cyclooctene, we add hydrogen, it will become cyclooctane. The last thing that you have to be aware of the definition of aliphatic compounds. Aliphatic, it means alkane, alkene, alkyne, cycloalkane, cycloalkene, and cycloalkyne. While the aromatic compounds, they are the compounds that they are connected to a benzene ring.